Good afternoon. This is Dr.B.Vijayakumar, Head of the Department of Physics, SNS College of Engineering. The another one topic we discuss application of superconductor Cryotron. This is under the magnetic and superconducting materials. Unit 4. So the brainstorming session question is, do you know the application of superconductor and what is the use of cryotron and what are the application of superconducting electronics? This is all the three questions you get the answer after the taking of this topic. So the application of superconducting material, the engineering application, since there is no loss in power, so the superconductor can be used for the transmission of power over very large distance. The superconducting property can be easily destroyed. It can be used in switching devices. The variation in small voltages cause large consist current. It can be used in a very sensitive electrical instruments, example galvanometers. Since the current in a superconducting ring can flow without any changes in its value, persist current, it can be used as a memory or storage element in computers. Then medical field, the superconducting material are used in NMR, nuclear magnetic resonance imaging equipment, which is used for scanning purpose. They are applied in a detection of brain wave activity such as brain tumor, defective cells, etc. Using superconducting magnet, one can separate the damaged cell from the healthy cell. Superconducting solenoids are used in a magneto-hydrodynamic power generation to maintain plasma in the body. So we start from the topic is a cryotron. The cryotron is a magnetically operated current switch. The principle, the superconducting property disappears when the magnetic field is greater than in a critical field of Hc. So this is a coil to wounded in that. The one end is A, another one is in a B. So let us consider a superconducting material A surrounded by the another superconducting material B. So the critical field HCA of the material in A less than the critical field of HCB of the material B. Initially, let temperature of the whole system be below the transition temperature of the two materials. So the operating temperature, the magnetic field produced by the material B may exceed the critical field of A. Hence the material A become normal conductor because the critical field of A is less than the critical field of B. Also B will not become normal conductor at the critical field. Therefore the current in a material can be controlled by the current in a materials. So it's act in a relay or switching elements. So this is two types of superconductor to be act in that. So based on these two types of material property, it will be act in the switching device to be applied of external field of AC or DC. So the superconductor, one of the property is in a diamagnetic property. So this diamagnetic properties is applied from these devices. It's act as current switching devices. So that is an act of diamagnetic property in a material to be clearly shown that. Also to be identified the small sensitive devices to be acted. So the small sensitive flux also to be penetrate. The device is changed from act of switching device, current switching device. So the minute current, micro level ampere current also to be affected in this material. It's act on a proper switching device. It's a very important device to used in electronics formations. So this is all the reference I prepared this PPT. Thank you very much. We discuss in another one topic in another one video. Thank you.